Hi, everybody. So I'm here to talk about tokenomics as a layered cake approach and looking at how we can drive more efficiency. So before we get into how do we solve this problem, let's understand classification of use cases. So as I see it, there are two broad classifications or groups of use cases that we see across product AI, which is customer facing that your customers are seeing, and the second one is internal. So this could be use cases about coding or internal workflows. And the reason it's important to classify these two separately is because everything that we talk about in terms of tokenomics ties back into what is the use case, because that drives the budgets, that drives how we measure ROI, that also drives how we think about efficiency. And tokenomics itself, like the cost of tokens, is a ratio question. It's not a question about absolute cost, right? So what we want to understand is first thing first, the industry is evolving. We are in very early phases, and so understanding of metrics is rather immature. We're trying to figure things out. There's tokenizing going on. People are trying to figure out ways to optimize against the metrics we put forward as practitioners. But what ends up happening is at the very core, we need to be able to figure out how do we provide people with more tokens. Well, in order to do that, we have to drive efficiency. We have to be able to create the headroom necessary in the system. But at the very same time, we also need to make sure we're being careful about the governance, because we don't want to stifle use cases. We want people to be able to experiment these use cases. Many of them will fail, but if you have some use cases that are super successful, that more than makes up the value that we are putting as investments in this space. Okay, so what that means is in order to create this headroom, so let's say you have $100 budget of tokens. In order for you to be able to get more done, either you need to have a more innovative or a smarter model. You need to be able to drive more tokens for that model, or you need to be able to go and optimize the use case. So what do we do? So what we're proposing is, let's have a 5-layer cake approach, kind of like what Jensen said. Let's put it like Jensen. So first thing first is silicon and hardware. So there is no replacement for lithography. Once a silicon is etched, it's practically written in sand. So you can't replace it. So an optimization that is done at the fundamental hardware level is irreplaceable. So when you have hardware that supports things like MXFP4 quantization, you're going to get more performance out of it. As you can see, for those of you trying running LLMs against Hopper versus Blackwell, you can see the dramatic jump in performance. What we want to propose here is the fact that all of these layers compound. What that means is at each layer, as you drive efficiency, you're compounding that against all the layers, and also they sometimes overlap and interact with each other. So let's go through the layers. First one, silicon and hardware. Second one, capacity. Well, it's great to have hardware, but if you have no power, no data center space, what are you going to do with it? You have a bunch of chips that are sitting there. Secondly, if they happen to be in a different physical location, you have to now worry about data movement, and now you have all of a sudden your cost of tokens now has to factor in how to move data around. The third one is the inference stack. Optimizations of the inference stack, whether you're using vLLM, SGLang, some proprietary stack, matters. And in conjunction with that, also matters is whether you're KV caching. So some of the previous presenters talked about this. Every time you're sending a request to the LLM, you're sending the entire context length. And does it make sense to be safe for you to be saving the entire KV cache from some chat 30 days ago? Probably not. It depends on the retrieval. So you don't really want to it's not a one size fits all approach. But the point is, these are optimizations that are in place, whether it is quantization of KV cache, whether it is the KV cache itself, matters. And that it matters with is the inference engine itself. So apply the inference engine, apply these optimizations, and then we keep going up that stack. Next comes model and quantization. Do you want to use the same model? So you want to use a 1 trillion parameter model for writing a simple script that does, let's say, a bunch of directory of file renames? Perhaps not, right? Because that task can be done by a cheaper model. And so it's important to understand what model is being used for the task. At the same time, what quality level is that model being set at? So whether thinking budgets are on, whether it is looking at what quantization level it's running, just like what I mentioned in terms of hardware, being able to drive, let's say, MXFP4 quantization, you will get more performance out of the same model. And last but not the least comes the routing and governance layer. So what matters here is you can force people and use cases to go to specific models. So if it's a simple task, you do not want it to be routing to an expensive model, whether that is self-hosted, whether that is an external inference provider, and you want to be able to understand that in tie up with the governance aspect. So when you set that token budget, you're setting that token budget and providing people the ability to be able to go and optimize and route to the right model. Again, you don't want to have everybody in the company trying to figure out, is this the right model for this use case? Can you create templates that allow automated routing? So these are 5 layers that can be used. These are mechanics. We're not getting to the specifics how you apply them. These are just options on the table as your use case, and how do you use them matters from use case to use case, whether it is coding, whether it is internal agentic workflows. It's going to change the equation completely as how these are configured and structured together. So to put it all together, taking agentic AI or even AI workflows from development to production, what matters is the three-phased approach. As we talked about the layered cake, where are tokens made? How are they being made? How are they being monetized? And that matters based on the use case that they're being applied towards, whether that is, again, internal workflows or product-centric use cases. Because for product-centric use cases, if you're really making revenue or making your product smarter, you can charge your customers more. You can make more value out of them. And in that case, you can just buy more tokens because you're producing value at the end of the day. So apply the core takeaway message from this presentation is to look and explore these different criterias and understand how do you apply them together, and how you use these techniques in conjunction with each other to be able to have productivity driven without stopping because budgets ran out. So again, we're trying to be to loop it all together. We're trying to say, how do you create the headroom for the tokens in your company so that you can drive more of these use cases, not block people over, but then being able to still drive the productive outcome at the end of the day. Thank you.